So in addition to this previous fast revision PID controller, just to show you the design of the PID controller. This is the design of PID controller, and here are the elements. Here is the quadcopter system represented mathematically, and here is the angular rates PID controller, and here is the altitude PID controller, and the translation positioning of the PID controller. Basically, PID shows a good controlling stability and simple design, and we can see the result of this. Here is the output of the PID controller. As one of the advantages of PID controller is the ability to control the quadcopter with easy design. Over here you can see the simple programs of this design. So here is the PID design, and here are the subsystems of the PID, and here are some of the representations of these systems. So to go further, hence we are trying to build a system that is able to control the movement of the quadcopter in smooth way. So starting with this video, which indicates the high dynamics that quadcopters can provide. In fact, nowadays quadcopters are having very high dynamics designs and ability to be controlled and with very smooth motion. Here is another video and shows the very high synergic dynamics of this system playing together to enhance the movements. The future of quadcopters can be very interesting and can solve a lot of problems due to the dynamics of the plant. Basically, before we go to the Q-learning in quadcopter, I'm going to make a very fast revision of deep learning. Basically, it is very good to know how does the neural network actually work, and a simple example of the deep learning is the conversion of the sound to a texting using deep learning algorithms. So basically we have an input which is a sound frequency over here, and the neural network converts that signal to text can be displayed on a monitor or an handphone device. So how does this algorithm actually work? Actually, it is starting from getting an analog audio. This audio is converted digitally. These kind of frequencies are converted to a pictures, so the neural network is able to read these kind of pictures accordingly. Then this picture can be converted to a text. So again we come to the progress recovery. We have designed a PID controller to control the system. To go further, we are trying to employ the reinforcement learning. Reinforcement learning requires a lot of data input and a lot of training of that agent. To simplify this sector of our design, we need to know that machine learning includes major three types, which supervised learning and unsupervised learning and reinforcement learning. Supervised learning is a part of the machine learning. It gets a data from an input, and it is supervised by the programmer to classify that data systemical way, which is the classification. Another sector of machine learning is unsupervised learning, the ability of the algorithm to classify data without any supervision of the programmer. Furthermore, our interest in this project is the reinforcement learning. Reinforcement learning is the ability of the model to learn from the scratch.